Good day, quitters. We are the hierarchy of Terra, and for today's module, we will tackle about geological dating. But what is geological dating? Geological dating uses the presence of temporary radioactive elements to determine the age in years, underlying geological materials. The other term for it is radioactive dating. For example, you're digging in your backyard and find layers of dirt with the different things buried in them. By studying these layers, scientists can tell which things are older or younger than the others.
But what is dating? It is the technique used to determine the age of the rocks, minerals, fossils, and artifacts. The types of dating methods are relative dating and absolute dating.
Here are the topics that typically included in geological dating. Radiometric dating. Radiometric dating techniques provide an absolute ages by measuring the decay of radioactive isotopes within the rocks and the fossils. For example, carbon dating and the uranium-lead dating. Stratigraphy. Stratigraphy is a branch of geology concerned with the study of rock layers or strata and layering or stratification. It is mostly applied to the study of layered volcanic and sedimentary rocks. The three related subfields of stratigraphy are called chronostratigraphy, also known as stratigraphy by age, biostratigraphy or biologic stratigraphy, and lithostratigraphy or lithologic stratigraphy. For example, showing the stratigraphy diagram. At the bottom, you might have a layer of shale representing an ancient seabed. Above that, there could be a layer of sandstone, indicating an beach environment. Next, there might be a layer of limestone, indicating a period when the area was underwater. On the top of the limestone, there could be a layer of volcanic ash, suggesting a volcanic eruption nearby. And finally, there might be a layer of soils and debris, indicating a period of erosions and decomposition. Each layer tells a story about the environment and condition during a particular time period. Paleomagnetism is like an Earth magnetic diary. Imagine Earth as a giant compass needle always pointing at north. But this needle isn't fixed. It wanders over millions of years. Rocks form with the tiny magnetic materials aligned to the Earth's magnetic field at the time. By studying these rocks, scientists can figure out where Earth's magnetic poles were in the past. Here an example of paleomagnetism diagram. Let's say lava solidifies into rocks. The magnetic minerals in the lava align with the Earth's magnetic field. If the lava cools during a time when the magnetic North Pole is near the geographic North Pole, the minerals will point towards today's North Pole. But if the pole has shifted over time, the minerals will point elsewhere. By analyzing many rocks of different ages, scientists can track the movement of Earth's magnetic field.
Dendrochronology dating. It uses tree rings to determine the age of trees and environmental conditions. For example, by counting the rings of a tree, we can estimate its age and understand past climate variations. If a tree has 50 rings, it's approximately 50 years old. An example would be dating wooden artifacts found in ancient ruins by matching their tree rings patterns with existing tree ring sequences. Relative dating determines the age of geological formations by examining their position in relation to one another. For example, if a layer of rock containing fossil A lies above a layer containing fossil B, we can infer that fossil A is younger than fossil B. An example would be identifying the age of dinosaurs fossils by examining the layers of rock they found in, with different layers representing older time periods. Biostratigraphy dating correlates the age of rocks by comparing the fossils they contain. For instance, if a certain species of marine microorganism existed during a specific time period, finding its fossils in a layer of rock helps determine the age of the rock. An example would be dating sedimentary rock layers by identifying index fossils such as trilobites which are indicative of a specific geological time period.
Thermoluminescence dating. Thermoluminescence dating measures the light emitted from crystalline materials when they are heated. It is often used to date pottery or ceramics. Thermoluminescence is useful for ceramics because it determines the date of firing as well as for lava or even sediments that were exposed to substantial sunlight. For example, this is how thermoluminescence dating works. Imagine if you have a pottery shard buried underground for a long time. While it is buried, it is observing tiny bits of radiation from the environment. When you heat it up, like by firing it in a kiln, it releases that observed energy as light. By measuring how much light is emitted, the scientists can figure out how long the pottery has been buried.